Welcome to The Explainer. Today, we're going to put ourselves in the shoes of a startup that's facing a massive challenge. How do you navigate the wild world of large language models? By the end of this, you'll have a super clear playbook for how to choose, test, and, ultimately improve the right AI for whatever job you have in mind. So if you're looking to build something with AI, this is probably the first, and let's be honest, most overwhelming question you're going to face. The sheer number of choices out there is kind of staggering. But don't worry, there really is a clear path through all that noise, and we're going to walk it together. So here's our game plan. First, we'll get the lay of the land. What's even out there? Then we'll dig into the core differences that really matter. After that, we'll lay out a practical way to actually pick a model. And finally, we'll talk about how to make your choice even better. All right, let's get into it. Okay, the first and probably most important thing for our startup to realize is that not all models are created equal. I mean, you wouldn't use a hammer to screw in a light bulb, right? The same exact logic applies here. The model you pick depends entirely on what you want to get done. So let's say your goals has anything to do with audio, maybe transcription or speech recognition. You'll want a specialized model. A fantastic example is Whisper. It was trained on this huge, diverse data set of audio, which makes it incredibly good at understanding different languages, accents, and even dealing with background noise. Now, what if you need to create visuals from scratch? Well, now you're in the world of image generation. This is where those famous models like DALL-E and Midjourney absolutely shine. They're built specifically for turning your text prompts into art, editing images, and all that cool visual stuff. And for the classic stuff, generating text or writing code, you have a massive spectrum of options. You could go with something like GPT 3.5, which is really cost-effective and fast. Or you could scale up to the more powerful and, more expensive GPT-4 for those really complex reasoning tasks. Figuring out that trade-off between cost and capability, that's a critical first step. So what happens if you need to handle multiple types of data at once? That's where these new multimodal models come in. The latest ones, like GPT-4o, are just amazing because they combine language processing with visual understanding. They can literally see and talk about images, all in the same conversation. Okay, so we've got the basic categories down, right? It's all based on the task. Now let's go a layer deeper. We're going to get a little more technical and learn the lingo that really separates these models, looking at everything from the business decision side of things to their core architecture. So this right here is a fundamental business decision. Do you go with an open source model like Llama that gives you the freedom to look under the hood, modify it, and really customize it? Or do you opt for a proprietary model from a company like OpenAI? These are super polished, production ready, but they're also a black box. You can't see how they work inside, and you're typically paying a subscription or usage fee. Now, to understand the architecture, let's use an analogy. Think of a decoder-only model, like GPT-3, as a super creative content writer. It's incredibly good at looking at what you've already written and then just generating the next word, and the next, and the next. Its whole job is to create new, fluid, and engaging text. Its main skill is generation. On the other hand, you've got an encoder-only model, like BERT. Think of this one as the meticulous reviewer. It reads an entire piece of text all at once to understand the deep context and the relationships between all the words. It's brilliant for analysis, like figuring out if a review is positive or negative. But it's not designed to write new stuff. So what happens when you combine those two? Well, you get the encoder-decoder model. And as you can probably guess, it uses both skills. An encoder reviews the input to understand it, and then a decoder creates a relevant output. This two-step process makes them perfect for tasks like summarizing a long document or translating between languages. All right, the final distinction here is a really practical one. Are you using a service or are you using a raw model? A service, like the one Azure provides for OpenAI models, wraps everything up in an easy-to-use package. They handle the hardware, the scaling. You just pay as you go. The alternative is you can grab a model like Llama and run it yourself. But that means you're responsible for all the servers and managing the whole infrastructure. Okay, so we've just covered a lot of theory, but theory is one thing. How does our startup actually, pick one? Let's get super practical and walk through a clear step-by-step framework for testing and choosing the right model for the job. So platforms like Azure AI Studio make this a really structured process. First, you find a model in their catalog. Then you review its model card, which is basically a spec sheet for the AI.
Next, you compare its performance on industry benchmarks to see how it stacks up. After that, you can optionally fine-tune it on your own data to give it some specialized skills. And finally, you deploy the winner so your application can actually start using it.
Now, selecting a base model is a huge step, for sure, but it is not the end of the story. Your first choice is really just a starting point. Let's look at how our startup can take that base model and basically upgrade its performance to perfectly fit their specific needs. There are really three main ways to get better results, and you can think of them like a ladder of increasing cost and complexity. The first rung is prompt engineering. The next step up is something called retrieval augmented generation. We just call it RAG. And the most advanced is fine-tuning. The real key is knowing which one is right for your situation. Prompt engineering is the easiest way in, low cost, low complexity. It's really just about getting better at writing clear, detailed instructions for the AI. RAG is that middle ground. It lets the model access your company's private data to answer questions. Think of it like giving the AI an open book test using your company's documents. And finally, fine-tuning is the most powerful option. It actually retrains a part of the model on your own data. But it's expensive, not just because of the computing power, but because of the human cost of gathering and labeling thousands of perfect examples for the AI to learn from. And there you have it. By following this whole journey, from just mapping the landscape and understanding the core differences to running a structured selection process and planning for upgrades, you've turned what feels like this impossibly complex choice into a strategic, step-by-step decision. So now you have the guide and the framework to confidently navigate the world of large language models. The only question left is, what incredible problem are you going to solve with it? Thanks for watching.